In this tutorial, we learn about the Binomial Expansions Formula, or Binomial Theorem. Now, the whole idea here is to learn how to write all the terms in the expansion of any binomial a plus b raised to a power n, where n is any integer greater than or equal to 0. Now, what the binomial theorem tells us is that this is equal to the sum from r equals to 0 up to n of the terms which are made of the product of the binomial coefficient nr times a raised to the power of n minus r times b raised to the power of r. Now, if you hadn't seen this formula before, do make a note of it now, as it is essential to know this when working with binomial expansions. To learn how to use this formula, we're going to work through an example. A plus b raised to the power of 4. Well, comparing a plus b raised to the power of 4 to a plus b raised to the power of n, we can see that the only difference is that I've replaced n by 4. Consequently, all we have to do is copy the right-hand side of this formula, replacing every n that we see by 4. So let's go ahead and do that. We can state that this equals to the sum from r equals to 0 up to 4 of the binomial coefficient 4r times a to the power of 4 minus r times b raised to the power of r. And now to write all of the terms of this expansion, we're going to focus on the expression that I'm currently underlining in green. This is known as the general term of this binomial expansion, and I like to call it TR, T as in term. To be clear, each and every single term in the expansion of a plus b raised to the power of 4 is obtained from this general term. And what this summation symbol is telling us to do is to add all of the terms we obtain by replacing r inside this general term by all of the integer values between 0 and 4. In other words, this sum is equal to t0 plus t1 plus t2 plus t3 plus t4. At this stage, there's already an important rule that I'd like to point out. We can see here that we have 1, 2, 3, 4, 5 terms in this expansion. But the binomial a plus b had been raised to the power of 4. And in fact, this highlights an important rule. When we raise a binomial a plus b to a power n, this will always lead to n plus 1 terms. So for instance, if we have a plus b to the power of 2, then we'll have 3 terms. Or if we have a plus b raised to the power of 5, then we'll have 6 terms, and so on. Okay, now that we've seen that we have 5 terms in this expansion, how do we actually find them? Well, for each of these terms, t0, t1, t2, t3, and t4, we obtain the term by replacing r inside the general term by the corresponding r value. So for t0, that would be 40 times a to the power of 4 minus 0 times b raised to the power of 0. Notice that all I've done here is copy the general term and replace every r that I see by 0. And I do the same for t1. Here I'll have plus 41 times a to the power of 4 minus 1 times b to the power of 1. And I do the same for t2. So plus 42 times a to the power of 4 minus 2 times b to the power of 2. I do the same for t3, in which I copy the general term and replace every r that I see by 3. So that's 43 times a to the power of 4 minus 3 times b to the power of 3. And finally, I do the same for t4, for which I copy this general term and replace every r that I see by 4. So that would be 4 times a to the power of 4 minus 4 times b to the power of 4. And at this stage, we've written all of the terms of the expansion, and our job now consists of tidying this up a little bit. And the first thing I'll do is simplify all these powers of a that I see here. This equals to 4, 0 times a to the power of 4 times b to the power of 0 plus 4, 1 times a to the power of 3 times b to the power of 1 plus 4, 2 times a to the power of 2 times b to the power of 2 plus 4, 3 times a to the power of 1 times b to the power of 3 plus 4, 4 times a to the power of 0 times b to the power of 4. To be clear, all that I've done here is calculate what each of the powers on each of the a's actually is. Now that we've reached this stage, I'd like to point out a second important point. Notice that on any term inside this expansion, if I add the power on the a with the power on the b, it always equals to 4. Indeed, looking at this first term, 4 plus 0 is 4. On the second term, 3 plus 1 is 4. On the third term, 2 plus 2 is 4, and so on. And this will always be the case. And it's always worth checking that when you write all the terms in the expansion of a plus b raised to the power of n. Okay, now that that's said, we can simplify this further. In particular, any power of 0 that we see, as well as any power of 1 that we may see, can be simplified. And here's the idea. Any non-zero number raised to the power of 0 is simply equal to 1, so we don't need to write that term. So for that first term we have b to the power of 0 equals to 1, and on the last term here we have a to the power of 0, which also equals to 1. Another important thing worth pointing out is any number raised to the power of 1, which we have here, b to the power of 1, and a to the power of 1. Any number raised to the power of 1 is simply equal to itself. So b to the power of 1 is equal to b, and a to the power of 1 is equal to a. Keeping all of these things in mind, we can now write the expansion as 4, 0 times a to the power of 4. Notice that I'm no longer writing the b to the power of 0, plus 4, 1 times a to the power of 3 times b, plus 4, 2 times a to the power of 2 times b to the power of 2, plus 4, 3 times a times b to the power of 3. And finally, plus 4, 4 times b to the power of 4. Notice again that I've gotten rid of the a to the power of 0. And at this stage, we have written all of the terms in the expansion. But we have one more thing to do. Indeed, we need to calculate each of these coefficients that we have here. These are known as binomial coefficients, and they're given by the following formula. A binomial coefficient nr is equal to factorial n over factorial n minus r times factorial r. And in fact, I'll go ahead and box that formula. Do make a note of it if you hadn't seen this before. If you're unsure of what a factorial actually is, here are a couple of reminders. Factorial 4 equals to 4 times 3 times 2 times 1, which equals to 24. That's just a quick example. Another example could be factorial 3. That will equal to 3 times 2 times 1, which equals to 6. In other words, the factorial of a whole number equals to the product of that number with all of the positive whole numbers less than it. Two important results are the following. The factorial of 1, which equals to 1, and factorial of 0, which equals to 1. Now the purpose of this tutorial more than anything else is to know how to write all of the terms of the expansion. We're going to dedicate 2 entire tutorials on this binomial coefficient. So for now, I'm going to solve this quite fast. And in the process, I'm going to give you a couple of tricks. The first is, the first binomial coefficient as well as the last binomial coefficient are and will always equal to 1. So I can go ahead and state that this equals to 1 and this equals to 1. A second trick that will always be true, the second binomial coefficient as well as the second to last, or the one before last, will always equal to the power to which we raise the binomial. So in this case, 4. So without even thinking, I can state that 4, 1 equals to 4, and 4, 3 equals to 4. So looking at this, the only binomial coefficient that we really need to calculate is this middle one that we have here, the binomial coefficient for 2. And I'll do that on the right-hand side here. The binomial coefficient for 2, using the formula that we have here, equals to factorial 4 over factorial 4 minus 2 times factorial 2. And that's equal to factorial 4 over factorial 2 times factorial 2. In turn, this is equal to 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. And simplifying this as much as possible, we see that we have 2 times 2, which cancel out with the 4. And so we're simply left with 3 times 2 times 1, which is 6, over 1 times 1, which is 1. So this binomial coefficient equals to 6 divided by 1, which is equal to 6. And we now know the value of this middle binomial coefficient. Now that we know the values of these binomial coefficients, we can state the final answer. A plus b raised to the power of 4 is equal to 1 times a to the power of 4, which is a to the power of 4, plus 4 times a cubed times b, plus 6 times a squared times b squared, plus 4 times a times b to the power of 3, and finally, plus 1 times b to the power of 4, which is just b to the power of 4. And that's the final answer. The method we've just seen will always work when writing all of the terms in any expansion of a plus b raised to the power of n. As good practice, you can go ahead and try to write all the terms of a plus b raised to the power of 5, of 6, of 7. In our next couple of tutorials, we're going to spend some time looking into the binomial coefficient, as well as learn why the first and last coefficients are always equal to 1, and the second and second to last are always equal to the power to which the binomial is raised. For now, though, that's it for this tutorial.